Hello, everybody. Thanks for joining us today. We're going to show you how you can stretch your application from an OpenStack to a public cloud, or vice versa, from a public cloud to an OpenStack-based cloud. And we're going to show you how to do that securely and efficiently with a project called Istio. Hope you all enjoy what we have to show you. My name is John Joyce. I'm a principal engineer at Cisco's Cloud CTO group.
I'm Tim Swanson. I'm a senior tech lead at Cisco with the Cloud CTO group. So I'm going to bring us through the agenda here. And so we're going to start off with an introduction of Istio and service meshes in general, the idea of a service mesh. And we're going to go over Kubernetes on OpenStack, specifically the pieces that pertain to Istio. And then we're going to go through multi-cluster architecture. So Istio in that environment has some specific requirements. And then we're going to go through a deployment of Istio in a multi-cluster environment. And we'll show a deployment in action. And we'll do a demo. So introducing Istio here, extending applications across multiple clouds. So as applications have been decomposed into microservices, there's been a strong desire to place those microservice instances anywhere. And we want to be able to do that very safely, and we have all the same degree of control that we currently do in a single cloud. We want to be able to run those on a public cloud or private cloud or wherever. So that's the idea. So Istio has the concept of a service mesh, and it gives you a lot of those type of features to safety, placement, and routing capabilities. So we want to be able to have Istio, a service mesh, be stretched across multiple clouds. So in this talk, we're going to talk about OpenStack and a public cloud service mesh with an example application, microservices deployed in each of those clouds, and have it work seamlessly. So how many people know what Istio is or have been introduced to Istio before? So it's a pretty good amount. Basically, the idea is that Istio is a service mesh framework that gives you a uniform way to connect, manage, and secure microservices. There's a lot of features that Istio microservices get by being involved in a service mesh. Mainly, one of the nicest one is automatic multi-protocol load balancing and traffic controls like service endpoint aware, traffic routing, circuit breaking, fault injection. And Istio also provides a pluggable policy layer in a configuration API to add some additional controls. And another really nice one is security. So security between all the microservices in the mesh is something that you just get with an Istio solution. So a service mesh, what are we talking about here? The details of how a service mesh is implemented are we're trying to represent them in this slide by showing interconnection of all of the instances of microservices, their APIs, via these application proxies. So the application proxies provide an infrastructure that gives a data path from microservice to microservice. This is how we support, the multi-protocol, traffic routing, security, API, like their metrics and stuff like that get supported just automatically because of the capabilities of the proxy and the control plane that Istio provides. So to go through this talk about deploying Istio in a multi-cluster environment, it helps to understand some of the components of the Istio architecture. So Istio adds, Envoy is another project in the CNCF, and Istio adds a control plane on top of that. So it deploys Envoy sidecars with each individual microservice instance, and it has some control plane components that provide the configuration to the sidecars, and then add additional features in the data path as well. So pilot is the thing that is the guy who knows all the logistics of who's in the mesh, how any changes that have happened, any routing rules that have been applied, that gets all conveyed via pilot. Mixer is a component that provides like telemetry collection and some server-side security policy, like quotas or just blocking traffic on server side. Istio Auth is a component that's now called Citadel. That's the auth-z, auth-n, cert and certificate and secret and key synchronization mechanism for both the control plane and the data plane. So between envoys and between Envoy and the control plane, Istio Auth takes care of that. So this is just another slide that shows, so basically the primary difference between this slide and the last one is the Citadel is the official name now of Istio Auth. So now we're going to go over Kubernetes on OpenStack and how Istio, the things that are provided by Kubernetes, an integration of Kubernetes on OpenStack, and how that helps out the Istio solution. So the idea for Kubernetes on OpenStack, we just want to be able to have a user that's a Kubernetes admin, use some OpenStack APIs to create a Kubernetes cluster, and then turn that over to give access to that Kubernetes cluster to a Kubernetes user. And then the Kubernetes user is not using OpenStack APIs anymore. They're just directly interacting with Kubernetes, creating pods and services and stuff. So how does a Kubernetes admin do that? So Kubernetes needs things like load balancers and storage and stuff. So there's this thing called in the Kubernetes architecture called a cloud provider. And cloud providers are pieces of software that end up that run in the Kubernetes control plane that end up invoking OpenStack APIs, and for the OpenStack cloud provider case. So for the main scenario for Istio is the Kubernetes load balancer service type. It needs to have a corresponding OpenStack LBAS load balancer created. When you enable otherwise you need another type of external load balancer and some other special integration with OpenStack. So the OpenStack Project Magnum installs Kubernetes and automates the provisioning of the OpenStack cloud provider in Kubernetes. And with Octavia, the cloud provider will cause OpenStack load balancers to get created. So this is an illustration of that. When the Istio ingress is a component that fronts the entry to an application in the service mesh, and that Istio ingress is implemented in Kubernetes as a load balancer type service. And when you install Istio, that's going to cause this Istio ingress to be created, and the OpenStack cloud provider will in turn create a load balancer object in OpenStack. And at that point, it'll also plumb the endpoints and stuff in the load balancer API. So you'll have a service VIP, and you'll get endpoints automatically just by interacting with the Kubernetes API, which is really cool. So this is what it looks like when you, this is just like kind of a generic view of two Kubernetes load balance type services. And this is the neutron topology view from Horizon. On the right, you see there's several VMs that contain that implement a Kubernetes cluster, and they have an OpenStack cloud provider, and that cloud provider has created 2 Octavia load balancers, and that's what these Amphora VMs in the middle are. They are those are individual load balancer instances for services that are on the that have been created by Kubernetes. So this is an animated slide. I'm just going to go through it fast. So the multi-cloud topology here, this is intended to show there's several ways to create. This is Shannon's slide. There's several ways to create a multi-cloud connection to from an OpenStack cluster to a public cloud. And the main idea is having a VPN into the public cloud from your on-prem or OpenStack cloud. And the differences between the 3 scenarios here are just where the terminating point in your data center is, in the on-prem data center is for that VPN. So in the left side, that's just a hardware edge router or having a VPN, terminating the VPN to the on-prem, to the public cloud. In the middle, this is more typical of what we do a lot in testing. You have a virtual router in the same environment as in your OpenStack environment as a VM or something, and that ends up terminating your VPN and providing the VPN connectivity to that OpenStack network. And then on the right side, this is more of an integrated with OpenStack view of having a neutron router actually terminate the VPN. So you have you're using the VPN as a service API to achieve that. So next, we'll talk about Istio multi-cluster architecture.
So just also on the last, the OpenStack and the VPN connection, there is a talk later in the week that Shannon's doing. We'll cover some of that if you are interested. So we're going to shift focus here a little bit. That was more the OpenStack side. Now we're going to talk a little bit more specifically about the Istio pieces. Okay, so this is kind of showing you how we put together the Istio pieces and how we extend the Istio to make sure that it's multi-cluster or can stretch across the clouds. And what we do here is we tell Pilot, as Tim was saying, Pilot is the component that sort of controls the mesh and puts together the mesh and describes the topology of the mesh and drives that topology into the proxies, so they're aware of the mesh topology. So that's done by Pilot, and basically what we've done to make Istio multi-cluster aware or multi-cloud aware is to basically the first step is to make sure Pilot is able to see all the Kubernetes servers and able to watch for services and endpoint discovery and all the Kubernetes clusters that it's listening to. And as Tim was describing here, what we show on one side is the OpenStack cloud. In this particular case, we put the primary control plane in GKE. That's kind of arbitrary. It could be switched around. But primary control plane is in GKE. And on the OpenStack side, all we really have is Istio-Citadel. And we need Istio-Citadel on all the remote clusters in order to be able to provide the certs and the secrets to the application so MTLS can be done across the mesh. So let's see. Here's a little bit of a dive down into how we do that and how the service discovery happens. Basically, within Pilot, there's a service registry, and that service registry is taking the service and endpoint data from all the different clusters. It's compiling that into a cache. It's also taking other config stuff like the route rules, the Istio route rules, or our load balancing rules, or other configuration describing how you want to route requests across the mesh. It's taking those and it's pushing them into a cache. And then when Envoy, as the proxy, Envoy is actually pulling that cache when it needs it. So when Envoy says, hey, give me my cache pertinent to my particular pod, in my particular sidecar, Pilot will serve out that what Envoy refers to as its XDS. It's the X for RDS, CDS, discovery service. DS is for the discovery service. So this is how Envoy gets its config with respect to the mesh and the routing rules and how the request should go. As I show here, and as Tim was showing before, Envoy is a sidecar. It's packaged alongside all the microservices. So every pod, every microservice pod includes Envoy as a sidecar. Okay, so in addition to what we described before with how Pilot gets its information, this covers how Envoy knows how to communicate with Pilot to get that information. So what we're showing in this figure is that we've extended Istio and Envoy, so every Envoy is pointing back to the singular Pilot to get its data and to get its XDS discovery or its sort of mesh configuration. So the application pods can be deployed on any of the clouds, and we'll get into a little bit more detail of how we expose that Pilot to Envoy across the clusters in a few slides. Okay, so we talked about Istio-Citadel. This is a very key component for the security perspective. In this demo, we're going to have MTLS between, like across the mesh, so it's going to be across the clouds. And in order to do that, we have to have the proper certification being deployed out to all the applications, as well as the Istio control plane itself runs like I mentioned previously. If I go back, I mentioned Envoy gets its data from Pilot. That's via TLS path, so you have to have certs at the control plane level between Pilot and Envoy as well. So what we do, what we've done in this multi-cluster extension to Istio is we've deployed Istio-Citadel on all the pods, and we get that chain back to a root cert so that as the certificates are rotated and stuff like that, the MTLS will continue to work at both the control plane and the application plane. So I'm going to go into a little bit now what our deployment looks like. I have a few slides on what our deployment looks like, and then I have some screenshots on the deployment. The deployment takes a little while, so we didn't actually capture that as a demo, but I have some screenshots showing what it does. So a couple of environmental requirements that are in order if you wanted to duplicate this at home, or some environmental requirements that are currently necessary. So the biggest thing is there must be IP reachability between all the clusters. Tim got into that a little bit, and that's both for the control plane and the application plane. They have to have reachability across those clusters. The Istio community is working on some solutions to change that, but for now you need that reachability, and the easiest way to achieve that reachability is via VPN at the current time. It's not. You could do other things if you wanted to. We haven't explored those, but that's the most obvious and easiest thing to do. The other big thing that's a requirement is that the applications rely on kubedns. Any Kubernetes application does. So with respect to kubedns, even when you're trying to resolve applications that might span, like let's say you have an application, a microservice over here, and it's trying to, and we'll show this later, it's trying to get to a service, another microservice called ratings over here. It's going to try to do the DNS resolution in its local cluster. So you have to make sure that each of the clusters have the proper DNS population so that the microservice can resolve in its home cluster where that service will be. The service doesn't have to exist in the home service, but DNS has to be populated in a way so that resolution can happen. And we'll get into it. We'll show you a little bit of examples of how that happens in a bit. So what we're going to do in this particular demo, and we kind of showed this a little before, we're going to deploy a number of applications on the GKE side, and then we're going to show just Istio-Citadel on the OpenStack side. That's the control plane. I don't have a slide for this necessarily, but this kind of represents the application plane in a slightly different view. In the application plane, we have a Istio uses an application called Bookinfo that they use for a lot of testing. It's also very cool to show routing rules and stuff like that, so it's very easy to see how the mesh works. We're going to use that application here in this demo. This shows the deployment of that application. The blue represents everything that's going to be on the GKE side, and in this particular case, we only deploy one of the microservices on the OpenStack side. And that's called what we call, actually, let me be a little bit more specific. We deploy a specific version of the application on OpenStack. The actual microservice is deployed on both clusters, but only a particular version is deployed on OpenStack. So just so you can follow the demo, because especially if you're not familiar with decomposing an application in microservices, it can be a little confusing, but this slide is going to show you how the requests go. Tim's going to show you the actual live demo, but this will show you how the request goes. So an end user will make a request for something called a product page that comes in through the Istio ingress, as we talked about a little bit before, to a service called product page, which handles the base URL for that request. Product page does another request to something called reviews, and in this case, I only show it doing reviews v3. Depending on load balancing and your route rules, it can go to v1 or v2 based on how you're defining that, how you define your rules. It also goes to another application microservice called details. Now, the interesting part that you'll see in the demo is reviews needs to get its information from ratings. So in this case, what you'll see is product page will go from GKE to OpenStack, back to GKE, and then that all gets served back to the end user via the GKE pod. So again, just keep that a mental image of that as you'll see the demo in action. It'll be a little easier to see that. OK, so now I'm going to try to show you what we did in the deployment. Right now, we have what we labeled on-prem. That's the OpenStack side. And GKE, at the initial state is we just have Kubernetes running. And then we're going to start deploying the Istio. Now, in this particular case, what we did to do our deployment is we use some end-to-end capabilities in Istio. This is part of the Istio CI system. And since we were, since we're familiar with that, it was very easy for us to just do a few tweaks to that end-to-end system and just deploy the Bookinfo application exactly as we wanted to.
And underneath the sheets, that uses the same Helm charts as in the Istio documentation that you would use as the preferred install mechanism. So. Yeah, so as Tim was saying, the end-to-end pulls from the Helm charts that if you went to Istio to install, more or less manually or via some of your own automation, use those Helm charts. The tests use those Helm charts. This is actually with the command starting to run. You can see actually how we start to deploy the services. Command finishing.
Okay. And this is still going through it. Now, so this is the result. Okay, the pink shows the sort of Istio control plane components. You can see the upper window, which is GKE, has quite a few components. And the naming has evolved a little bit. That's why some of our slides don't match the exact naming here. In the last couple of weeks, the naming of the Istio services has morphed quite a bit. So ignore the naming a little bit. But the bottom line is you have Pilot, Mixer, and Citadel more or less with some different names. Then you have the app pod, which is shown in blue. The key one that we'll first hit is product page, but you can see there's a few others. And then the reviews, V1 and V2 are over there. We'll get into that again because we'll have another version in a second. And on the OpenStack side, we only have Citadel at the moment. We haven't done any app deployment. OK. And what we're showing here is the services view of the for both sides. On the top side, the service view is more or less normal. You'll have cluster IPs and ports and endpoints for most of those services. But on the on-prem side, you don't. On the on-prem side, as I was kind of describing before or inferring before, is you more or less are pointing those services back to the GKE side. So you have to have a representation of that service for kubedns to resolve it, but the actual backing of that service isn't on OpenStack. It's going to be back on the GKE side. Okay. And this kind of gives you a little bit better view of that. If you look at the red highlight, you'll see that the Istio pilot endpoint, which is actually backed in the GKE side with that IP, is represented with the same IP on the OpenStack side, but there is actually no physical backing of that pilot service on the OpenStack side, as I showed you previously. So the Istio ingress, as you can see here, there's only a single ingress shown. So all the traffic, any external requests into this microservice are always going to be from the GKE side in the way we set this up. And now what we do here in this little step, and this we don't use the end-to-end infrastructure for this. We had to do this manually because that's not currently yet in the Istio code base. But we basically are now deploying that singular v3 application. And as I mentioned, we also have to deploy, we have to do something to tell kubedns in OpenStack side about the rating service, because that reviews v3. Microservice needs to access the rating service itself, so we need to tell something, we need to do something in Kubernetes to tell kubedns about that. So we do that as a selectorless service. And if you look now, we have both a ratings and a review service on the OpenStack side, and we have cluster IPs assigned to them. And if this is some debug output that we do. This is showing sort of some more detailed mesh configuration, but basically this is a service, SDS is the Envoy service discovery information. And here what we're showing is that there's a review service that's shown in the SDS. And more importantly, if we look at the endpoints associated with that service, you can't see the whole thing here, but you can see that this is the review service. You can see there's 3 instantiations. One, which is the top one, is V1, which is in GKE US West. The second one is V2, which is also in GKE US West. And the third one, which is just shown as an IP, is the one on the OpenStack side, which is reviews V3. So now I'll pass it back to Tim, and he'll actually show you this in action.
OK, so I got a VPN is still up. So I'm going to show how that basically we're starting from the same situation that we were in where John just presented, where we have the reviews pods in GKE and a singular reviews v3 pod in the OpenStack cluster. So this is the GKE view. You can see the workload information, and the only reviews pods you see there are reviews 1 and 2, and the ratings pods are here in GKE as well. In the this bottom piece here, my VPN bounced, so let me. Get to see me restore my screen here. Whoops. OK. So this is the bottom terminal. I don't know if you guys can see that well enough. So this is the Kubernetes cluster and on the OpenStack instance. So we just get the pods here. Everything we put it in the Istio system namespace. That's partially because of the way that end-to-end tool works. So you can see here the only pods that are running, this is the only microservice instances that are running on this OpenStack cloud are the reviews v3 pod. So and it's got a sidecar just like these other guys on the GKE cluster. So the sidecar is the Envoy proxy, and that Envoy proxy is talking to, John just showed in the debug output, it's talking to the pilot back in the GKE cluster. So it's getting all of its routing information, or its endpoint information from that, and its routing rules and stuff, and pilot's giving the routing rules out. So what we're going to show is, if we look quickly at the slide with the picture, we're going to show different ways of sending the traffic around between those reviews instances. Excuse me. So this is going to show the pods again, just to reiterate that. So these are the services that are running in the cluster. So this is the view of more like the high-level view of the application. So you have the ratings, reviews, product page. Those are the main services for this app called Bookinfo. And the endpoints of those services are shown by Kubernetes get endpoints, and you can see in the Kubernetes view of those endpoints is still just local here. But so we're going to apply. So let me just show the way the application looks at like right now. So when we look at the product page, this is the Bookinfo application in the GKE cluster. We have this. We modified it to show where the right side here with the stars. That's where the information that's retrieved from reviews is rendered. And so the product page is getting, in this instance, this refresh of the Bookinfo app is getting the reviews v3 data from the OpenStack cluster. In this one, it's going to, the load balancer is equal right now, so it's just going to round robin between all of the instances of the reviews pod. And so that time it was from GKE, and it's got black stars, so that means it's reviews v2. So this time, there's no stars.
So we didn't really explain,
yeah.
Right? So two of the versions, the reviews versions will show from GKE, and whether it's v1 or v2 depends on whether there's stars shown or whether they're black stars or no stars. So basically, between the text and the stars, you can tell which version of the reviews is actually being rendered.
And you can see in the case of reviews v2 and reviews v3, they both go to this ratings pod. So reviews v1 is not, so it doesn't have any stars. So
and right now it's just load balanced equally between the three.
Right. So I'm just going to refresh it a billion times here so you can see that it crashes occasionally. So so it's equal cost right now. So what Istio allows you to do is apply route rules. So what we're going to do here is we're going to have Istio apply rules for sorry, this should be, see, I'm playing with my demo beforehand. I commented out a lot of things that I was doing before. So what we're going to do is start off with 50-50 between the v1 and v2 rules. So we're going to, or reviews version. So what that's going to do is just have black and have no stars and black stars. So it's only going to go to the GKE cluster. So sorry, I'm going through this. So now the way that we apply those rules is with this Istio-Ctl tool. It's like a custom tool, but you can do this with kubectl as well. This just wraps some usage of the custom resource types that Istio defines. So these rules shows the way you define rules for this custom resource type route rule. It has a ways to indicate like the application that the microservice instance has labels on it in the metadata, and one of those labels is version, and this rule is allowing you to match on those labels and weight the traffic as 50% for that version. So we have just two sections here, so that's V1 and V2, each weighted 50%. So that's going to cause 50-50 traffic load balancing between these two reviews, V1 and V2.
We've got about 10 minutes left.
Okay. So we see 50-50 here. It's not exactly sequential, but the gist is like if you refresh 4 times, 2 out of the 4 were each type. So next, we're going to show how we can layer rules. So there's another, this just shows that it got applied. So then there's another rule that we have for just, say I have a canary deployment, it's reviews v3, and I want to just apply it to the special user JSON. So on the metadata for the header, we want to be able to match on a regular expression that has user equal to JSON, and apply this rule for going to all the traffic going to version 3 of the reviews microservice. So this is how you would do that. And this rule is applied in conjunction with the other existing rules. So it just doesn't change the fact that the other rule is still operating on all the rest of the traffic.
So we didn't get into this too much, but this shows a very fine-grained control that Istio allows, because you're actually able to match on metadata in the request, the user, in this case, a particular user.
So you can see as I refresh, it's still doing 50-50 between the reviews v1 and v2, but when I sign in as JSON here, all the traffic is going to start going to for the user JSON is going to go to the reviews v3 instance in the OpenStack cluster. So that's a very simple example of how you can control traffic there. If I sign back out, it goes right back to the other rules. So then, hey, I've decided, okay, that canary version is great. Let's make everything go to reviews v3. So I can just apply a rule like this. This is going to be clobbering the existing default rule with a precedence of 1, and it's going to apply that for any certain microservices that have that version v3 label. It's going to send it, add it to the load balancer for 100% of the traffic. So let's apply it. So now reviews v3 is the rules taken over. So now all of the traffic is going to that reviews v3 microservice in OpenStack, no matter what user I sign in as. So that's the gist of what we wanted to show, route rules wise and demo wise. Let's finish up with, so we have, I gotta change my, turn the mirror displays off. You guys can tell I do this a lot, huh? So there's some future improvements in the Istio community for multi-cluster in general. Usability is one that we're working with the SIG multi-cluster Kubernetes community on that as well, or just in general picking up, sharing what they've done there. You saw how we manually deployed the different instances. The SIG multi-cluster guys have a much more nice set of tools that they have planned for that. We want to increase test coverage, obviously, to harden this, and work on solutions that don't involve VPN. I think those are the main ones. DNS naming and scale and performance, those are also key things for this type of environment. So we can open up for questions, and just I'll leave the references slide up here if anybody has any thoughts, questions that they want to ask. So the references, these are Istio references. There's a Kubernetes OpenStack cloud provider reference here. We're having another talk at the end of the week on more Istio and Kubernetes OpenStack cloud provider work that's been done, and that's Thursday at 4:20, I believe. And then again, on the multi-cluster architecture, Shannon McFarland's got a presentation on that as well, I think tomorrow. Yeah. Yep. Can you go to the mic so that they can get in on the video? Or if you ask me, I'll repeat it, that's fine.
Hey, I was just wondering if you have any comments on how this compares to other hybrid Kubernetes architectures like open service broker architecture or virtual kubelet, compared to those options.
Well, so the open services broker is more about how you convey the location of a service. So it's more about like the service naming and how an app can learn where the service sits. This is a little bit more about how you manage the plumbing so that you can get to that service.
And between the instances of the microservice, so it's like with metadata associated with each microservice, you can apply, you can control deployment, I guess usage of the individual microservices. But
also to your question, that's the fourth bullet there about how you handle the DNS integration. That may get wound around the service broker. We're still trying to figure out exactly how that all fits together, the best way to do it. But Istio itself is less concerned with how an app learns about the service naming and more about, okay, if I have that name, how do I get to that service? So it's a slightly different, part of the problem that's looking at. But they're not. But they are related. So it's a good question.
Yeah, I think some of the work that's done for just federating or stretching Kubernetes would, like John said, it's kind of like Istio could exist on top of any of that. The Istio level is sort of just going to be built on top of the infrastructure provided by whatever Kubernetes architecture you have. And what the Istio multi-cluster specifically has done is just allow Istio itself to understand multiple kube API servers, that they exist, and then some glue to make deployment of apps that run within the Istio mesh work well in that architecture. So if there's other kube federation enhancements or other models for federating or for having a multi-cluster view of Kubernetes, then Istio should be able to, as long as there's a sort of an endpoint that can give the service discovery framework that Istio has the information. And that service discovery framework is pluggable, so if there is a modification. So Kubernetes is just one environment that Istio supports. It supports like Console and Eureka, and the thing we're going to show later in the week is just like a raw VM, how you could plug that into the Istio mesh.
I think there's time for one more question, if anybody has any more questions.
Did you?
No? Okay, well, thanks everybody for coming.
Thanks.